Internet of Things, reinforcement learning, game theory, and network optimization. He was obtained his PhD in from NIT, sorry, from IIT Guwahati in the year 2018. He has 10 plus years of teaching and research experience. He is also a senior member of IEEE. He has published in various reputed journals and conference proceedings such as IEEE Transactions on Network and Service Management, IEEE Communication Letters, Computer Communication Elsewhere, Computer Networks Elsewhere, and others. He also delivered various guest lectures in several short-term courses at IIT, IIIT Dhanbad and NIT Raipur. Presently, he is guiding one of the students, Sudha Sagar, for our PhD. Thank you, sir. Thank you for accepting our request. You can go ahead with your session, sir.
Thank you. Thank you for inviting me for this for this FDP. And the topic that was assigned to me is on reinforcement learning. So in this 2 hour session, the first 1 hour or 1 hour 15 minutes, I will talk about all the terminologies, basics, and the theory that is required. And in the last 45 minutes or 1 hour, I will demonstrate an application of reinforcement learning using Python. So that application is called self-driving taxi. So we'll see what is the advantage of training this agent. Agent means here self-driving taxi using reinforcement learning. So we'll see the improvement in terms of reduction in penalty and the number of steps that are required. So we'll see that there is a huge improvement where if we train the agent using reinforcement learning. Okay, all right. So this is the overview of the presentation. Let me maximize screen. Okay, so this is the overview of the presentation. Initially, I will talk about what is this reinforcement learning problem, where exactly it falls in different fields of science and engineering. And then I will introduce some basic terminologies and important components inside reinforcement learning, such as important components such as agent, environment, important terminologies such as reward, action, observation. All these things I will introduce slowly. Then we will dig inside this reinforcement learning agent. So this reinforcement learning agent will have some important concepts known as policy, value function. So one has to understand this policy and value function in order to understand how this RL reinforcement learning works. So that's why we'll discuss this policy value function with an example also. Then I will shortly, briefly demonstrate a reinforcement learning algorithm called Q-learning, which is one of the basic algorithm in reinforcement learning. Then in the demonstration, we will apply this Q-learning algorithm on self-driving taxi. So this is the overview of the presentation. So let's start our presentation, our discussion. So what exactly is this reinforcement learning? So before defining what exactly is this reinforcement learning, let us see where exactly this reinforcement learning falls. Now, as you can see this Venn diagram, we have different circles here, right? These different circles represents different fields of science and engineering. As you can see, computer science, neuroscience, psychology, economics, mathematics, engineering, and so on. And within each circle, we have something that was highlighted in red. As you can see, in computer science, we have something called machine learning, mathematics, operations research. In economics, bounded rationality, which is also known as game theory, right? In neuroscience, they have a subfield called reward system. So if you see the reinforcement learning, it is the center of all these subfields. That means what? There are many different fields of science and engineering, and each of these fields of science and engineering have a subfield like machine learning, optimal control, operations research, game theory, and so on. So in computer science, we study this reinforcement learning under the umbrella of machine learning. And what these mathematics people, they study under the area of operations research, and what we study under the umbrella of machine learning, which is reinforcement learning, are more or less similar. And what economics people study under the umbrella of game theory is more or less similar to what we study under the umbrella of reinforcement learning. Now the question is, okay, they all do more or less similar, right? Game theory, operations research, reinforcement learning, right? All this. Now what exactly they are trying to do under the umbrella of game theory, or what exactly we are trying to do under the umbrella of reinforcement learning? So basically, the reinforcement learning is the science of decision making. So before understanding what is this science of decision making, let me introduce the important components inside reinforcement learning. So as you can see in this figure here, we have two components here, right? The others are arrows. So mostly we can find out here that broadly there are two components. So the component that was on the top side was represented with brain, and the component that was on the bottom side was represented with globe center, right? So the component that was on the top side is called agent. The component that was on the bottom side is called environment. So these are the two important entities in reinforcement learning. One is agent, the other one is environment. Now what is agent, what is environment? So agent is basically a software program. What it will do will come again, but it is basically a software program. Agent is a software program, that's all. It is a piece of code. Now what is environment? Environment can be softwareized or it can be real world. That means environment can be a real world environment or simulated environment. Simulated means it is inside computer. So let me give at this point let me introduce some classical examples of reinforcement learning so that you will understand what an environment is. So one of the classical example of reinforcement learning is that a child learning how to walk for time. So when he was very small, he tries to walk, then he will fall down, right? Then again he will try. He will try and try. He will fall and then he will make a progress that okay, he will do 1-2 steps, then he will fall. Then again he will try. Then he may make a progress of 3-4 steps, then he may fall. Right? Then he may use support and he may able to walk. And finally he may walk without falling. Right? So here the child trying to learn this walking, this example, the child tries to walk, then he will fall down, right? So that is called interaction. So we have to aware of these terminologies. What is an interaction? Interaction means, you see in this example, the child is learning, right? Learning is learning how to walk. Now he will try to walk and then he will fall. So that is one interaction. Again he will try to walk, then again he will fall. That is second interaction. So these are called interactions. Now what is the environment here? The environment in this case is your floor, right? Which is a real world environment, right? It is a physical environment which is a real world environment. Now in this case, the child is the agent. So the child is trying to learn this walking. How he is trying to learn? How he is learning the walking? By interactions, by repeated interactions, right? So he will try to walk, he will fall, he will try to walk, fall, and so on, so on, so on. Then he will make a progress of 1-2 steps. Then he will make a progress of 4-5 steps. Then he will try to walk using the support and so on. So these are called interactions. So the agent will interact with the environment, and via these interactions, the agent will learn. Now the question is, okay, we have an agent, we have an environment. Let me give one more example. The other example of reinforcement learning is a software program running on your system which is playing chess with you. So in this case, what is the environment? Environment is not a real world environment. It is not a physical environment. It is a simulated environment, right? So an environment can be a real world environment or simulated environment. Now what is agent? Agent is a software program. Now, okay, what is the responsibility of this agent? So agent responsibility is to pick actions. Now, the actions means, okay, let us say the child is walking, you are standing at the other end of the room, right? Now, the child may move towards you, right? And the child may move in other direction such that he will get some support. Using that support, he will walk towards you. So let me show you here what I'm trying to say. Wait, let me show you. So let's say child is there. Right? He was trying to walk or crawl. Okay, walk, let's say. Now you are at this end of the room. You are standing here. This is the goal. So he has to reach you. Now there are some supports. Here there is a support like this, let us say. Right? If he tries to walk this way, after 2 steps he may fall. But somehow he gets holds of this support, then using this support he may be able to walk. Right? These are actions, moving in this direction or moving in this direction or moving in this direction or moving in this direction. These are called actions. Right? Now which action the child should pick? Right? Which action the child should pick? So this is the decision making problem. This is the decision making problem. Which action he has to pick at every point in time. Again, after going here, again he should continue going in this way, or he should, let us say the support was in this direction. Let us say not in this direction. The support was like this. Let me draw in different color. The support was in this direction. It was like this. Let us say the support. Now in which direction? Will he go forward or will he go in this direction? So this is the decision making problem. At every point in time, at every time step, the child has to make a decision in which direction to move, right? So child means the agent. So the agent is responsible for these actions, selecting these actions. Okay, let me see some. Okay, no chat. Okay. So if you have any questions, you can post in chat box or you can enter to me. Okay. So I hope you understood. So we have agent, we have environment. Agent interacts with environment. How it interacts? Via actions. It has to pick actions. It has to make a decision at every point of time. So that's why this is called science of decision making. So at every point in time, the agent is responsible to pick an action. Okay. Now, what action he will pick? This is the question. Now he has multiple actions. He has multiple actions. Now which action will pick? That action, what action he will pick? He will learn from all the interactions. So how he will learn now? Now the question, okay, he will learn now. It is simply saying that he will learn our interactions is not enough. How he will learn? So he will learn via interactions. That means he will take an action, but there is a response from environment. So environment will give something called reward. So based on these responses, the agent will learn. How he will learn, we will see later. I will come again. So I hope you understood the broad idea of reinforcement learning. We have two entities, agent and environment. Agent interacts with environment via actions. And environment, what? In response, environment gives something called reward. What is this reward? I will discuss. So this is a broad idea of reinforcement learning, and we study this under the umbrella of machine learning. And as you know, there are other machine learning paradigms such as supervised learning and unsupervised learning, right? Now the question is how this RL is different from supervised learning and unsupervised learning. This is the question now. How it is different? So the first difference is that in RL there is no supervisor. Then immediately one will ask, unsupervised learning also there is no supervisor, right? So we have supervised learning, unsupervised learning, reinforcement learning. In supervised learning we have something called supervisor. Yes. In reinforcement learning, there is no supervisor. In unsupervised learning, you can see no supervisor. So now one may ask how it is different from unsupervised learning. So there is a difference called feedback. In reinforcement learning, there is something called feedback. In unsupervised learning, there is no feedback. Now you may ask, what about supervised learning? Is the feedback is there? Supervisor itself is enough. There is feedback is not required. That's why there is no feedback in supervised learning. So supervisor itself is enough, means he himself, supervisor himself, captures this feedback mechanism. Now, if you want to understand these differences in a real world way, let me present it this way. Let me take this example. Example of a quiz. Quiz. Let us say this quiz has 10 questions or 20 questions. Multiple choice quiz, right? MCQs. Some 10 questions are there, 1, 2 to 10. Now, user, you are the user, you attempted the exam. You gave some answers, B, C, D, A, something like this. If you have answered the questions. Now, let me give three options. Option 1, option 2, option 3. In option 1, at the end of the exam, it will display the correct answers. You understood? You have attempted the quiz. And at the end of the exam, the correct answers are available to you. Like the correct answer is C, the correct answer is C, the correct answer is A, the correct answer is something, the correct answer is B. Let us say B. Like this, the correct answers are available. These are the correct answers. Now these are the attempted answers. Right? Now the option 2. In option 2, these correct answers are not available. Nothing. Let us say you got marks also. At the end of the exam, you got marks also here. How many marks you got? And the correct answer for each question is available to you. In second option, these answers are not available to you. Just marks were given to you. In third option, you have marks were given to you. Marks were given to you. And for each question, whether it is right or wrong was given. Means whether it is correct or incorrect was given. So let us say this is incorrect. This is correct. This is incorrect. This is incorrect. Like this. That means this is incorrect. So this kind of information is available. This is wrong. Right? Now you see, this is the first attempt. Now, if you give the user a second attempt, a second chance, according to option 1, he knows what is the correct answer now. So he can correctly answer all the questions, right? Now you see the three differences. Now tell me which one is supervised, which one is unsupervised, which one is reinforcement learning. Anyone? Can you post? Can you relate these options with supervised, unsupervised, and reinforcement learning? Which one is supervised? Which one is unsupervised? Which one is reinforcement learning? You have to be clear with these options. You can post in chat box. Okay. So it is clear from this discussion that the option one is like supervised learning, right? Option two is like unsupervised learning. Option three is like reinforcement learning, because in option two, there is no supervisor, means nobody is telling you what is the correct answer and nobody is telling you the feedback. Feedback means, okay, whether it is right or wrong. Now you see the difference between one and three. In one, you are telling the correct answer for each question. In three, you are only giving feedback. What is that feedback? Okay, your answer is right or wrong. This doesn't mean what is the correct answer. The user knows what is the correct answer. No. You see, here you are telling C is incorrect. It doesn't mean the user knows what is the correct answer. Right? In this case, he knows, of course, but in this case also, there are three more options. So that's why it is like a feedback mechanism. You are telling, so feedback is like you are telling whether it is good or bad. You are not telling what is correct. Right? So the example, that's why with an example I have explained these things. So that is the first difference. There is no supervisor, but there is something called feedback signal. This feedback signal is also known as reward signal. Now, what is this reward? Let me ask. What is this reward and how this reward will be calculated? All this thing. So we'll shortly discuss this reward. And the other difference, let me write in paint only. It is good here. So the other difference is that in supervised learning and unsupervised learning, you work with some data set, right? The data set is a fixed one, static data set. That means suppose it has 5,000 samples. When you load in the data set, it contains 500 samples, means 5,000 samples means that your data set has 5,000 samples. It is static, fixed, right? And the training examples inside this data set are independent of each other. They are independent of each other, and then they are identically distributed also. That means they are drawn from same distribution. So which means this is the training examples inside the data set in supervised and unsupervised learning are IID samples. That means they are independent of each other. The training samples are independent of each other, and they are taken from drawn from same distribution, identically distributed. Whereas in reinforcement learning, the data is not fixed. The data is dynamic. The data is dynamic. Now, to understand why it is dynamic, let me explain this with an example. Why it is dynamic, so that you will understand these things better. What do we mean by data? Data means what the agent sees, what the agent can observe. So the data is also known as observations. So let us say we have this child. Now this child has moved in this direction. Now what he can see? He can see only this part of environment. Do you agree? Only this part of environment he can see. So this is the observation. The other hand, when it moves in this direction, the data it sees is different. Right? So you see the data is changing based on action. Right? When you pick an action A1, the data is different. When you pick action A2, the data is different. Right? Similarly, when you pick an action A3, the data is different. Let us say. So this data is also an observation. Observation.
అని చెప్పి నెక్స్ట్ అది కూడా గైడ్ పర్మిషన్ ఇస్తే మీరు ఆ క్లాస్ల వరకు వస్తే సరిపోతుంది, అడిగినా సరే పర్మిషన్ తీసుకుని ఆ క్లాస్ల వరకు అటెండ్ అయితే సరిపోతుంది అన్నారు. నేను విన్నదే కాదు. ఎన్ఓసి
Suppose he is always moving in this direction, then he will not see this kind of data. Right? On the other hand, if he is moving in this direction,
ఆన్లైన్లో సెషన్
he will not see these observations and these observations. Right? So the agent action affects the subsequent data he receives. So that's why this reinforcement learning is called passive learning paradigm. Why it is passive learning? Because the data is dynamic. Whereas, no, this is called active learning paradigm. It is dynamic, this is called active learning paradigm. Whereas supervised learning and unsupervised learning, they are called passive learning paradigm. Because the data is static or fixed data. I hope you got. So these are the differences. As you can see, this is the non-ID data and agent action affect the subsequent data it receives. Now, okay, I have given some examples. There are many other examples also. I will share the slide with you. You can go through them. Now what? Now the question is, okay, agent takes an action. He will get some reward. Now, what is this reward? What is the meaning of this reward? All this we will see. So reward is basically a scalar value. So reward is also known as feedback. So it is a scalar value. Scalar means what? As you know, the difference between scalar and vector. Scalar means a single value. Vector means multiple values, right? Now the question is, what exactly this value indicate? What exactly this number indicates? Right? Numbers should indicate something. Otherwise it has no meaning. Right? So let us say someone says 23. What is it? It should indicate something. Right? 23 marks or 23 what? 23 is your house number or something. It should indicate something, right? Now when we say it is a value, what it should indicate? So it indicates how well the agent is doing at any time step. That means, you see, agent, we have an agent here. We have an environment here. Agent picks an action. Let us say at time t. Because as I said, it is a science of decision making. The agent has to select actions at different points in time, right? At time t, the action that was taken was 80. Now in response, the environment gives a reward RT. So as we know, RT is a number. So it should indicate something. So what it indicates? It indicates how good is the action at time t. So let me explain with an example. Let us say RT value can be plus 100 or minus 100. Now based on this value, this plus 100 indicates that if RT value is plus 100, which means the action at time t is a good action. Minus 100 indicates that action at time t is not a good action. Let us say we have 4 actions. A1, A2, A3, A4. Now out of these 4 actions, you picked one action at time t and you got one of these rewards, let us say. Now this doesn't indicate, you see, this is the reward or feedback. So this reward or feedback does not indicate what is the best action, right? It was simply telling whether it is a good action or bad action. Bad means you will avoid from the next time. Good means, okay, you can use it from next time. But it does not mean that that is the best action. Now let us say the action that was taken at time t was A2 and which gives a reward of plus 100. On the other hand, if you take an action A3, it gives a reward of minus 100. So this doesn't mean A2 is the best action. If you pick an action A1, it may give you a reward of plus 500 also, right? So therefore, this feedback does not indicate, and let us say he has picked action A1. This does not indicate that A1 is the best action. A4 may give a better reward, right? Better value. So this is just a feedback kind of thing. So feedback means what? It will indicate whether it is good or bad. That's all. This feedback does not give any information about what is the best action. Of course, the agent will learn what is the best action over time. We have multiple interactions, he will learn. Are we clear so far? Any questions so far? Okay, now we have understood what is this reward. Reward indicates how well the agent is doing it at time step T. Right? Now, as I already mentioned, it is science of decision making. At time step T, he has to take a decision, T plus 1, he has to make a decision, T plus 2, he has to make a decision, T plus 3, he has to make a decision, T plus 4, he has to make a decision. Now the question is till when? Till when he has to make a decision? So till he reaches the goal, till the agent reaches the goal. That means, let us say, in our child example, goal is here. That means you are standing here. The child should reach here so that you will give something. Let us say chocolate you will give, or biscuit you will give. So this is the goal. So he has to pick this action until he reaches this point. When he reaches this point, there is no need to pick any further actions. So that means he has to pick these actions till he reaches the goal. Now, the question is, in what way he will pick these actions? So he will pick these actions, let us say 80, 18 plus 1, 18 plus 2, 18 plus 3, and so on. He will pick these actions in such a way that for every action you will get a reward, right? RT plus 1, let us call it like this. Now we will get these rewards. The goal of the agent is to pick these actions in such a way that the sum of rewards is maximized. You will get maximum reward. Sum of these rewards should be maximum. This is called cumulative reward. So the agent tries to maximize this cumulative reward. All right. So this example of rewards I will share with you. You can go through them. Now, let me introduce these important ideas. What is policy? What is policy? What is value function? Let me introduce. Then I will also introduce something known as what is Q value also. In addition to value, I will introduce Q value also. Now let me take an example again. We have a chain here, right? You are standing here, as we know. Now, let us say we have let me draw the support here. And we have another support also. And we have another support also. Now tell me, how many possible ways you can move from here to here? And this figure indicates that this is the first way, this is the second way, this is the third way, right? Now you see, these are called policies. So let me define policy, then you will understand what is this policy. So policy defines agent behavior. That means, let us say policy, let us represent policy with phi. Generally, we represent policy with phi. Now, you see, when you are here, you have two possible actions. Either you can move here or move here, right? Now let us consider a policy phi 1. Let us say we have three policies, phi 1, phi 2, phi 3 here. So phi 1 was telling you to move in this direction when you are here. When you are here, the phi 1 was telling you to move in this direction. The phi 2 was telling you to move in this direction when you are here. You move in this direction when you are here. Again, from you move in this direction when you are here, you move in this direction when you are here, and so on. Now this phi 3, it was telling you move in this direction when you are here, not in this direction. And when you are here, move in this direction. When you are here, move in this direction. When you are here, move in this direction, and so on. So as you can see, the policy here, someone is guiding you, right? Someone is telling you how to move, right? So that is called policy. Now the question is, you may ask, okay, someone is guiding you. So who is guiding you? Is it supervisor? No, someone means it is not someone. It is, this policy has to be built by, there are different policies. This policy, different policies means different ways in which you can go. So this is not someone was telling you. These are the three different ways you can go from here to here, right? So if you pick this decision, you will go in this direction and so on. So different possible ways we represent with policy. So policy defines agent behavior. That means when you are here, suppose you move in this direction. When you are here, move in this direction. This is one policy. This is phi 1, like this. Now, there are two types of policies. Before defining these two types of policies, so as I said, policy defines agent behavior. So what does that mean? So when you are in this state, what is the action at this state? Either should I move in this direction or should I move in this direction? Right? So this policy is a mapping between state to action. So policy is a function that maps the states to action. That means what? Okay, you are at this state S1. What is the action? You are at state S2. What is the action? S3. What is the action? S4. What is the action? S5. What is the action? S6. What is the action? And so on. So for every state, so if the agent is at some state, what action he should take will be defined inside the policy. So if the action corresponding to a state is fixed action, then we call it as deterministic policy. I will show what a deterministic policy means with an example, then you will understand. On the other hand, we have something called stochastic policy. So what do you mean by this stochastic policy? Stochastic policy means when you are at some state S, suppose you have multiple actions, you can pick multiple actions. Then the stochastic policy says that you pick action A1 with some probability, you pick action A2 with some probability. Whereas deterministic means when you are at state S, then he will tell that you take this action A1 with probability 1. Whereas here, so it is like this one. Probability that when you are in state S, what is the probability that you will pick action A1? What is the probability that you will pick action A2 when you are in state S? So these are probabilities. So this we represent like this, phi of A1 of S, phi of A2 of S. And as you know, this sigma phi of A1 of S, A2 of S, phi of AI of S to be equals to 1. These are probabilities, as you know. So this is stochastic policy. Okay. Now let me give example, then you will understand what is this policy means. Let us consider this simple example, grid world. As you can see here, the states are the squares, white squares, as you can see in this figure. We have the states, right? Now what are the actions? Some actions are moving left, moving right, moving up, moving down. They are simple actions. And reward is -1 for each time step. So no matter. So I told earlier that we have not discussed. In fact, reward RT I have not discussed this, right? RT is a random variable. RT is a random variable because the value of the variable changes with time. How it changes with time? Because the action that you take is different at different points in time, right? 80 plus 1 and so on. So therefore the value reward also changes. So it is a random variable. So it doesn't mean the value will change in all applications. In some applications it may be same also. In our application, the current application here, the reward is fixed reward. You make a move, you will get a reward of -1. You make a move and you will get a reward of -1. So this is the reward, -1 per time step. Now what is a policy? So a policy was shown here, you see. So at every state, the action was defined. So here arrows indicates the action, left or right or up or down. Right? As you can see, for every state, an action was defined. Any questions so far up to policy? These are some of the important concepts in RL. Policy. If there are no questions so far, then I will go to the value function. Any questions? You can post in chat box also. Okay, if no questions, no issue. Now let us go and discuss value. What is this value? So, right? Now, value is like a, what you can say, it is related to reward, but it is not same as reward. We have discussed what is reward, right? When agent picks an action AT, he will immediately get a reward RT. So that's why it is called immediate reward also. It's called immediate reward. Now what is value? First of all, value indicates it is a number, as you know. And here also I forgot to mention, reward can be positive, reward can be negative, reward can be integer, reward can be a fractional or continuous value, and so on. Now value. First of all, value is defined for a state. We define value of a state. Now, what does okay, earlier we have seen what the value reward indicates. Reward is a scalar value. What it indicates, we have seen. What it indicates how good is the action type. Now, what about this value of the state? What it indicates? It indicates the goodness or badness of state. Goodness or badness of state. So what is this goodness or badness of state? How do we define? And how do we can, first of all, we'll see what is the value